All right, for this one, let's take a look. Step 1, I'm going to test it out to see if f of -1 is defined or not. So f of -1, because the -1 has to equal here, so I'm going to plug into the second equation. So -2 times -1 minus 2. So this would be -2 minus 2. This is -4. So yes, pass. We can find the values, pass. So step 1, done. Now, what we're going to do is we go to step 2. So this is the left, this is the right limit. So for the left limit, you plug it in, you're doing the same thing, -1 plus 1, which is 0. Step 2, the right limit is, you already have it right here, which is -4. So if you compare, again, the limits fail. Whoops. If the limit fail, there's no limit right here because they're not equal. So we know this one is no limit. So this step failed. And we can say that the function is not continuous. Okay, so we can say f of x is not continuous at x -1. Okay. All right, let's look at the second objective. So we're going to do step 1 is that we're going to test out f of -1. Okay, so f of -1, I would replace into the one with the equal sign, so -2 times -1 minus 2, so this is 2 minus 2, that's 0. So step 1, pass, because we do have it. Okay, we have the 0. Even though it's 0, it's still defined. So now we go to step 2, what is the limit? Okay, so this is the left, this is the right. For the left, I'm doing the same thing. I plug it in, give me 0. For the right, which I already solved here, so you don't have to show the step again if you already plug it in. But on your paper, you want to show this to me. All right, you want to show that this is the left, this is the right. So left and right, so we have the limit. Therefore, the limit is this. Okay, that's the proper way we say there is a limit. Now what we're going to do is we want to go to step 3. Step 3 is that we're going to say, we're going to compare. Look at f of 1. Look at f of 1 is 0, right? The limit in this case is also, the limit is also 0 because they both equal to 0. So I'm going to erase this one. I would say limit f of x is 0. Okay, now if you compare, the limit is 0. So step 1 and step 2 equal. That means the function is continuous. So I can say f, this is the proper way of you writing f of 1 equal to the limit x approaching -1, f of x equal to 0. I'm going to try to rewrite this so you can read my handwriting a little bit better. -1 f of x. Okay, so now f of -1 equal to limit, but they both are 0. So we can say f of x is continuous at x equal -1. Okay, so this is the case when the function is continuous. Is that that function f of c is defined. There is a limit. and they both have the same values, then the function is continuous. Right, the last objective that I want to test is to solve for the constant, the missing letters, which is K in this case. It's a K, sometimes it's A, sometimes it's C, whatever they would tell you, okay? So step one, replace. Step 1, replace X. Okay, what do we replace the X with? That number for both. So you can do the first one is 5 squared. Set these to equal with each other, okay? And then 5 plus K. So 25 and 5 plus K. To solve for K, then step 2, okay, set them equal and plug in the X. Step 2, Step 2, we can solve K, right? So to solve for K, you minus 5 on both sides, so K is 20. And that's the answer that I'm looking for. So step 1, replace the X value. Step 2, set the two equations equal with each other. Step 3, you can solve for K. Or you can set them equal, and so this is step 3, I'm sorry. Solve for K, and step 2 is set them equal with each other. All right, let's look at another example. Let's do one more. So like I said, sometimes it's a C, sometimes it's a K, but it's going to work out the same way. So step 1, okay. Step 1, replace X. Step 2, set them equal. And then step 3, solve for C or K, depend on the problem, okay? So look at step 1, so 2 times 1 plus C equal to 1 squared plus 3. So 2 plus C. On this side, it should be 1 plus 3, that is 4. Then we solve for C, which is C equal to 2. So that is the step. So that's what you do to find that constant. So you say the function is going to be the function is going to be continuous when C is 2.